Hello friends, welcome to Java threading tutorial. In this video we are going to learn what is a cached thread pool and how to execute a task and the usage of executor service which will help in executing the task. We will also learn the execute method of the executor service. So executor is from java.util.concurrent package. So the executor will be useful to execute the task. Executor is a utility class which will simplify the thread creation and thread lifecycle management. So that's the advantage of using the executor. So you can avoid the overhead of thread creation and maintaining the lifecycle of the thread It returns executor service, otherwise called the ThreadPool. So from executor you can take executor service. So the executor service is otherwise called as ThreadPool via the call to net cached ThreadPool. So executor service, using the new cached ThreadPool method, you can get the executor service. So executor service is otherwise called ThreadPool. Right, the ThreadPool will execute a collection of threads. So people will use the name interchangeably. Some people use executor service, some people will call it as a ThreadPool, and you can get a ThreadPool using the new cached ThreadPool. That's a method call. So ThreadPool is a collection of pre-created threads. So that's why here we are talking about thread creation overhead that you can avoid when you are using the executor service. So ThreadPool means executor service is a collection of pre-created threads waiting to service the request. So the request can be anything. Say for example, searching for a specific IP address in a subnet mask. So once such a request comes, the thread will take that request and search the IP address. Then it will give you the host name and other details. So like this, you can imagine any task. So a specific order code. That's the request, and ThreadPool will wake up and performs the service. Or even the web applications. So request response processing cycle. When a request comes in, that is serviced by a ThreadPool. So there will be a thread in the ThreadPool which takes the request, performs whatever task on the middleware. It can be IIS server or some of the middleware application server, packs the response and gives it back. So that's the task of a thread. So when we use a ThreadPool, the threads are pre-created ones. So for each incoming web request, we can avoid the overhead of creating the thread. So you can imagine how many web requests a Google Merchant Service takes or a Amazon sales site takes, right? Alright, so ThreadPool is a collection of pre-created threads waiting to service the incoming request. The execute method of the executor service expects a runnable object. Why? Because it want to execute stuff in a threaded way, right? So execute method of the executor service or ThreadPool expects a runnable object and spans a thread or picks one from the pool to perform the task. And if you see the executor service, or we can call it as a executor is it's from a concurrent package, right? So you can get executor by using the executor service new cached pool. So here we will be having the ThreadPool in the sense it's a collection of thread. So if you see, there will be threads ready-madely available within a thread pool via the executor service, and one can make a call to execute method here. So in the early stage, if there are only one thread, whenever there is a execute call, the thread will get created in the thread pool. Let's say that our capacity is 4. So the threads will be created one by one, and after that, when 5th or 6th request comes, it will check any free thread, and the executor service will assign that thread to perform the task. So if you see, you will make a call to execute, and it will give any of the free thread in the thread pool, and engages that to perform the task. So if it is for the first time, then it will create a new thread, spans it, and executes the task. So after the task is executed, the thread will be returned to the pool again. So it will be taken out here to perform the task, and after that it will be returned back to the pool. So it will be given back to the pool. So once the thread is given back to the pool, it will look for any new request. So likewise, if we take our web server example, and let's state that thread pool's capacity is 150 threads, then there will be 150 threads waiting in the thread pool to serve any incoming request. So on a busy day, let's state that there are 154 requests in a given time, and let's state that by an average each request takes 10 seconds to respond. Then there will be a delay of 4 seconds for 4 people. Why? Because there is only 150 thread, all threads are consumed, and for this 4 request, there will be a wait time. So when some request is serviced, then the thread will be returned to the pool, and that knows that there is a queue which is waiting for the service. So it will be engaged here. The same way the executor service also work. We can have pool of, the collection of threads in a thread pool, and we can assign the task. So execute is one method that asks the executor service to execute a task. The task will be given to the executor service, and the executor service knows its internal thread pool and assigns this task to any freely available thread to service it, right? So shutdown method will clear the pool of threads. So this is the collection of threads. You can execute, you can make a call to shutdown. So the shutdown method will clear the pool of thread. After shutdown, the service will not accept any new task, because we already shut down the executor service, and all the thread pools or threads will get cleared out. So you cannot make a call to execute since we already shut down our executor service. Alright, in this video we will create a ticker runnable class and use ThreadPool to run multiple tickers. We already used the ticker, so it will be a thread that prints the sequence of numbers. So here if you see, our class name is ticker, which implements the runnable interface. Here we have a string. This is to denote the thread name, and another one is integer. Next, in the constructor, we are initializing the internal member end, then we are assigning the thread name. So end means, so when we are creating this ticker instance, we can tell where should the tick end. Say for example, if I say 4, then ticker will proceed printing 1, 2, 3, 4. So that's the use of this end. Here end is 4. So here is our run method. for this ticker. This time we are not extending from thread. Here we are using the runnable interface. So the run override is here. If you see, our loop starts from 1 to end, and we already stored here. By default it is 10, and we are overriding it. So this 10 assignment is not required here. Anyhow, here in the constructor we are passing the end. The loop runs for 1 to the series end, and periodically it prints the number. And in a second the loop will run for 2 times. That means it will print 2 numbers in 1 second. So that's the duty of this ticker. During the construction time it takes the thread name as well as the series end, and when you run the ticker it will create the sequence starting from 1 to end, and each print will take 500 milliseconds. So that's what this ticker is doing. And if you see, at present we just defined one thread, and the thread name is ticker here, ex05_ticker, and we will have this as a task in later stage. When we in the next slide you will see that. And the duty of this ticker is to print the number 1, 2, 3. It will go like this till the end, which we specified as part of the constructor, right? So to use executor service we are using 2 packages. We are using 2 classes from concurrent package. One is executor service and another one is executors. In the main, if you see, create executor and perform counting task, executors. So this is the executors, new cached thread pool. So here we are making call to a executors function, new cached thread pool. This will return an instance of executor service, and we are calling that as a thread pool. So executor service is nothing but thread pool. It will maintain n number of thread inside it, right? Next, if you see, we are running a loop inside the main. This will be our main thread. By this time you may be aware of it, main thread. And here we are creating a thread pool. Then we're creating 3 threads, 1, 2, 3, less than 4, right? So 3 times we are running this loop, and each time if you see, thread pool dot execute new, so we are creating a new instance of our runnable task. So this is nothing but a ticker, and here we can call this as a runnable task because our ticker instance implements the runnable interface, thereby providing the definition for run method. So here if you see, the end what we are giving is 4. So each ticker will run from 1 to 4. So 4 is the end here. And name what we are giving is ticker 1, ticker 2, ticker 3, like that. Since we are running it for 3 times, you will be getting ticker 1, 2, 3. That's the name given to the runnable task. And in each loop, if you see, thread pool dot execute, we are handing over the thread to the thread pool. So the thread pool will have 3 threads. So after we come out of this for loop, we are making call to thread pool. That's our executor service dot shutdown. So after this shutdown, we cannot execute any task. Also, even though main thread comes here, when you make a call to shutdown, the executor service will wait, because if all threads are engaged with a task, there are 3 threads, and if they are engaged with a task, and if a main thread is here at this stage, shutdown will not immediately shut down. It will wait for all thread to return to the queue. Once all threads are returned to the thread pool, it will clear out the thread and performs the shutdown action. So we call our executor service as, this is our executor service. So executor service is having a pool of 3 threads. So we can call all these as ticker threads or ticker task, and its duty is to print 1 to 4. All will do the same task because we are spanning 3 threads here, right? The loop will run for 3 times and we are spanning 3 threads, and all these will execute code in parallel. When times goes on, we will see executor service is using all 3 ticker tasks, or the task here is counting, so all 3 counting will goes in parallel. And since we have the thread name here as for example ticker 1, then you will see a sequence number here. That's how we are printing it, right, in the thread task. Alright, now let's go ahead and implement this. Now let's create a new class, and we will name it as ex05 ticker. So the ticker implements runnable interface, and okay, as explained in the slide, so here if you see, we have 2 member. This one denotes the thread name, and this is the end of the series. And since we are assigning that in the constructor, we will have it as a uninitialized member. In the constructor, we are setting the end as well as thread name. Then we have the void run. So in the run method, we can actually define the task, and here the task is simply a counting task which performs a print, and here we have a delay of 500 milliseconds. I will save this, and our ticker task is ready. Now we will go to the main entry, remove our previous code. So here if you see, we are creating the executor service. Executor service is from Java util concurrent executor service. So executors also from the same package, and this is a static method. And if you see, static method that returns executor service, right? So we have ThreadPool, and to the ThreadPool execute method, we are creating the instance of our thread and handing over that to the execute method. If you look at our runnable task, we usually use a runnable task with a thread inside. and we will make a call to thread.start. Right here, if you see, we avoid the overhead of thread. So we just defined a runnable interface and we specified the run override, and we don't have any thread instance inside it. It is not extending from thread, and there is no thread instance also. But this runnable task is given to the thread pool here, and this thread pool or this executor service will take care of creating the thread and assigning this runnable task to it. So we are running this for 3 times and we are creating an instance of a runnable task. The runnable task, if you see, it doesn't have any thread, but the thread pool will create one. And here, since we specified sleep of 1000 second, surround statement with a try catch, so after executing the task, we can shut down our thread pool. So that's all. Here we are creating a thread pool. This is thread pool, right? To thread pool, we are making the execute, creating our threaded task. Then after executing all the tasks, we are making call to the shutdown. The shutdown will wait for thread to complete. Now we will rebuild it and run it. So you can see 3 tasks will be executed in parallel. If you see ticker 1, then ticker 2, right? Ticker 2 and ticker 1 is executing in parallel, and here you can see ticker 2 and 3 is executing in parallel, right? So if I use here 14, then there will be more number of threads. That's all, right? You can see all tasks are performed here. So that's the use of executor service. So you have to define a runnable task, define your run method, and remember that your run method will be picked by the thread and it will be a threaded task. And here in the executor service, we create the executor service using the executors new cached thread pool. Then we submit our runnable task to the execute method of this executor service. Finally, we make the shutdown here. That's all here in this video. Thank you for watching. Bye.